Well, I am very excited to be speaking to you guys today about how KBI is transforming the CDMO-client collaboration through our custom client portal that we built using ELN as our basis. So today I'll be talking to you about one of the biggest challenges we have as a CDMO, which is sharing client data. Then I'll be talking a little bit about the vision that we had for solving this problem, which was to build our client portal. Then we'll do a little bit of a deep dive into the technical details as to how we actually leverage that data from IDBS. And then finally go through the impact and lessons that we've learned as we built this whole process. So for anybody who doesn't know, KBI Biopharma is a contract development and manufacturing organization. We have multiple sites across the US and Europe, and we support both mammalian and microbial processes. Since we are a CDMO, this means that none of the projects that we work on are for ourselves. Everything we do is for clients. And so one of our biggest challenges that we have is how do we compile all of this data and present it to our clients in a way that's very clear and so they can make decisions well and quickly to deliver medicines to patients. So next I'll go through a little bit about the scale of this challenge. So this is a typical upstream process development workflow for KBI. So we start with a molecule candidate, and then we scale up and refine that process until we get to our clinical material that we're going to be used for clinical studies. Throughout this whole journey, we might run up to 50 different bioreactor experiments. And for each of those bioreactor runs, we collect up to 200 different discrete data points and have 9 continuous different data attributes that we're streaming. Sorry. So all of this data adds up to thousands of different data points that we have to compile from multiple departments and systems and all of these different places. And then not only just compile it, but then prepare our presentations to our clients. And so with all of this comes a lot of complexity. And so we wanted to figure out how to streamline all of this. And this is just our upstream process development workflow. We also have a similar scale for our downstream process development as well. So that is the big question. How do we compile all of this data from all of these different systems and present it to our clients? So our vision for solving this problem was to build our client portal PROGRAMview. So here's just a high-level overview of how PROGRAMview looks. It is a one-stop shop for all of our communication and presentations between our internal teams and scientists and our clients. So we have all of our process development data inside of this system that's streamed directly from ELN. Inside of that, we also have the ability to share documents and have discussions on each of those data points. Then getting a little bit more into the experiments, you can click into the experiments and you can watch the experiment as it is executed real time. So as soon as the data is saved in ELN, or at least almost as soon, it probably takes about 20 minutes after an experiment has been saved for it to be fully processed and uploaded into PROGRAMview. So scientists and our clients are able to watch the execution of their experiments live inside of the platform. Once the experiments are done, we can also compare the results across multiple studies or programs and overlay trends and build your own customization for how you want to view your data. And then if additional analysis is required, you can download any of the data directly from PROGRAMview for your own offline analysis. So how did we actually build this? Here's kind of like a high-level overview of the timeline. So in 2017, we first implemented the IDBS ELN system. We started out with just one site, and it was really just paper under glass. Nothing was standardized or automated. We did have one analytical spreadsheet for recording all of our analytical results, but outside of that, it was really just Excel spreadsheets. 2020 was not great, but it did help us speed up our implementation of ELN because everybody needed an electronic system. And so at that time, all of our PD users were inside of ELN, and we also started to standardize our workflows and build out spreadsheets across our sites in different groups. In 2021, we built the initial proof of concept for PROGRAMview, but at this point, it was all Excel-based uploads, which was not very robust, but it was great that we could iterate quickly, but we needed a more standardized and robust process to stream the data into PROGRAMview, because as you know, users are always able to break Excel sheets. They're not very powerful for standardizing like a data pipeline to build a platform like this. So in 2022 is when we started streaming our data directly from the ELN system. But that was not enough for our clients to get the full picture of their experiments. So we had to pair the individual unit operation data from the spreadsheets with multiple spreadsheets inside of the ELN system. So pairing it with the analytical data and also streaming from additional data sources such as OSI-Pi. And so in 2023, that's when we started to automatically pair all of this data together for our clients. And then as of 2024, all of our core unit operations are supported inside of PROGRAMview. This includes 7 different spreadsheets, and it is across 3 different KBI sites. All right, so now how did we actually build PROGRAMview using the IDBS ELN software? So it all starts out with the ELN spreadsheet. You guys are all probably familiar, but for anybody who's not, IDBS has very robust spreadsheets inside of the system that solve a lot of the problems that Excel has. And so with Excel, it's both too flexible and inflexible at the same time. Users are always able to break things because it's too flexible. They could always just enter data in a different cell off to the side. Or change a column name even if you try to lock it down, which could break different data pipelines if you try to process it. But it's also not flexible enough in that you need to be able to configure the data so that if your processes change from one project to another, you have the available configurations to handle all of those different variations. And so that is where the IDBS ELN spreadsheet has solved all of those problems. So it is both very locked down. Users can't change any column names. They can't make edits that you don't want them to, but you can also configure the spreadsheet. There's a picture missing. Sorry. But you can configure the spreadsheet so that you can turn sections on or off. You can filter and remove tables if you don't need to do something for one type of program that you do for the other. And so the ELN spreadsheets are really what enable all of this data structure so that we can process this data to build our client portal. So the process that we use for extracting the data out of IDBS and into PROGRAMview, we actually follow an extract, load, and transform process. So we pull the raw data out of ELN. We process all of that data inside of our data lake to standardize and clean it. And then we display all of that data to PROGRAMview in a clean and structured way. And so what this data pipeline really enables is that we can have different views inside of the spreadsheet that are optimized for how the scientists want to execute their experiment. And we can completely separate that from how the clients or the scientists want to review their data after it's been executed. So in this picture on the right, this is PROGRAMview, and the data that makes up any of these tables inside of PROGRAMview, it might come from multiple different tables inside of ELN. And so we're able to standardize and structure that data throughout this data pipeline so that we can decouple the views so that everything, when a user is looking at their data, it's optimized for how they need so they can execute their experiment well and then also review their experiment and make decisions quickly. So the first step of this pipeline is to get the data out of the ELN system. And so in order to do that, we leverage 2 different APIs, the data space API and the REST API. So the data space API, this is really where you get the core spreadsheet data. It is a streaming API of spreadsheet save events that contains all of that raw spreadsheet data. But this in and of itself is not enough information. You also have to pair it with the REST API. And this is because data space does not handle renames, moves, or deletes of experiments or spreadsheets inside of the system. And so in order to ensure that we're maintaining accurate data in our data lake, we have to pair it with the REST API to query the system and get that experimental metadata. So it's always important to maintain, a clean data in your data lake, but it's especially important for us with PROGRAMview because our hierarchy inside of PROGRAMview mirrors the hierarchy inside of ELN as well. So in ELN, we structure things per project and then department and then study underneath that. And we follow that exact same pattern in PROGRAMview when we present our data. And so it's very important to maintain the state of experiment name or what study it's in or what project. If a scientist is moving around their data, we need to capture that exact hierarchy inside of ELN as well, PROGRAMview as well. So the next step of our pipeline is loading that data. So there's lots of spreadsheets that we have in the ELN system, but we want to only select the spreadsheets that we care about that have been structured and are following all the processes that we require in order to process this data. And so to handle this, we've implemented inside of the spreadsheets version control and spreadsheet type management. And so this is really important. If we know what the spreadsheet type is, then we know specifically how to forward process that data. We also have version control, and so we have major and minor versions, and this enables us to process and handle every version of our spreadsheets and integrate it into the same pipeline. And then as much as possible, we try to give users the flexibility to work in ELN however they need and to organize things in whatever is the most optimal way for them. And so almost all of this can be handled in our data pipeline, but there are certain things that we just can't handle programmatically. And so for any of those situations, we added warning bars inside of our spreadsheets so that if the users are doing something that we cannot handle programmatically, it's clear to them at the point of execution so they can change it. So like I was showing before, our hierarchy of PROGRAMview is dependent on those spreadsheets living in a study, so we can group the data together. And so if a scientist wants to, or is using a spreadsheet outside of one of those studies, we give them a warning because we can't handle this programmatically. So this is just one example, but there's a few different times where we've had to make sure the user is doing something correctly inside of the system. And so for any of those instances, we give them warnings inside of the spreadsheet as well. And then the last piece is how we actually load this data into the data pipeline. So we have different layers inside of our spreadsheets. We have the user interface layer, and then we have a layer where we send that data to the internal database of ELN. And we want to use that same data that's in the internal database of ELN to leverage the same structure outside so we can structure the data well. And so we actually leverage the same columns that are in our internal database in ELN outside as well. But one piece of this is that we can't rely on the database column names because those can be changed outside of version control of a spreadsheet. So we actually handle our renaming and our database mapping, I guess you could say, outside of ELN using the unique identifiers for any of those database columns. We manage that separately in our pipeline rather than relying on any of the column database names in the bioresults database. So with all of this, following all of these different principles that we've developed as we made this pipeline, we now are able to handle and process and clean this data so that it's structured and organized, and we can leverage it to build PROGRAMview. It took a lot of time to get to where we're at today, building all of these different pieces and coming up with these processes. But now that we have this pipeline standardized, as long as the spreadsheet follows the requirements that I've showed you guys today, we're able to add it directly into our new pipeline, maybe with 5 minutes of work, or versions. We handle versions in maybe an hour or less. And so, yeah, that's kind of where we're at today. So with all of this work too, it's already made a huge impact for KBI, and we're benefiting from it. We have 750 studies inside of PROGRAMview at the moment, and we estimate that each of those studies probably save scientists about 2 days of work to compile and copy all of that data from the systems to build their reports and presentations. Since we've removed a lot of that step by building PROGRAMview, we've now saved 12,000 hours to date for our scientists. And not only is this a huge saving for KBI, it also is very useful to the scientists, because this is all the work that we're removing that no one wants to do. Nobody wants to sit there copy pasting data, talking to other departments to find their experiments. So more specifically, it's 6 years of boring work, now that we've removed from our scientists' plate. There's also a lot of ROI that you can't measure. If we are able to improve our scientists' work and they're able to focus on what interests them the most, that's going to help with retention, and that just has immense value to KBI. And on top of that, our clients are very excited about the platform, and so improving that and having clients who want to come work with us because they get access to their data very quickly has been greatly valuable to us. And so what's next for KBI? So now that we have this data lake with structured data, all of our data inside of ELN is now structured outside of ELN, we can continue to build additional tools beyond PROGRAMview. And so we already have a bunch of tools that scientists want to build to analyze their data in different ways. As everybody's talking about, we're going to try to explore how we can use AI or machine learning to continue leveraging this data as well. And then as far as for ELN goes, we've focused most of our effort on data out, but now we really want to focus on data in. And so integrating those spreadsheets with other systems, connecting them to Empower, pH meters, all of those things to just continue improving and automating the scientist work. And with that, I just want to thank everybody who has helped us with the development of PROGRAMview. We're super thankful for our clients who have helped us and collaborated with us as we've gone through this journey. All right, and with that, does anybody have any questions?
So any questions? Oh, yes, we have a question for Christina. Just let me get a mic to you. Just hold it quite close to your mouth.
Hello. I have a question about how you develop the connection between the workbook and your AWS cloud data lake. Mm-hmm. Was that an in-house development? Yep. Did IDBS help? Okay.
Yep, it was completely in-house.
Okay, thank you.
The question was, how long did it take?
So building the data pipeline took probably 6 months, I would say. Yeah, and in parallel, we were building the spreadsheets and coming up with that process. But if we were to do it again, it would probably be around the same time.
Hi, I'm Sam from Lonza. You mentioned that you've got version control of your templates. Mm-hmm. They publish data within the eWorkbook IDBS platform, and then you take it out into your own one. If someone wants to update one of those templates to add new published data, how much effort is it to factor that into your system?
Yeah, so it depends on how big the scope of their change was. So in the versioning, I didn't mention it, but we have major and minor versions. So it said like version 7.2. So minor versions are anything that doesn't affect PROGRAMview and our data pipeline. So they can do those, and it is no effort at all to add that into PROGRAMview. If they do a major version, it depends on what they do. I would say if it's very simple, like adding a new column that they want to display to the clients, that's probably an hour of work, maybe less. I don't know. I don't want to say 5 minutes, but it's really, really simple. But if they're doing a very, very complex change and they really want to change how they show their data to PROGRAMview, depending on that, it could take a long time. If we have a brand new spreadsheet, it takes 5 minutes to get it into kind of like the initial clean state inside of our data pipeline, but then the transformations from there are really dependent on what they want to show to their clients. So that could be anywhere from like a day to a week. And if there's a major, version change, it would probably be similar to that.
Thank you.
That was a really great presentation, really interesting. One of the things I'm interested in is how, from a client's perspective, their control and access to data is managed so that they can't accidentally see someone else's data. And do they have any concerns about that with your data all coming from one central data lake?
We haven't had any concerns. I don't manage the controls of PROGRAMview on that side. Sorry, I know the data pipeline a lot better. So I'd have to ask specifically, but I do know we have a lot of controls in place for managing permissions so clients can't accidentally see the wrong data. But there's also additional features inside of PROGRAMview where scientists can choose whether they want to display a study to clients or not. So we have a lot of complex permissions and management there that I don't know everything about. But I'm happy to find the answer if you want to know more.
Christina, would you say that PROGRAMview is targeted to your clients only, or do internal users also benefit from that?
Yeah, internal users benefit a lot. We actually had a problem where we had a service that was down last week, and it was taking, so it normally takes like 20 minutes or less, but a max of 20 minutes to get the data. And last week we had a problem where it was taking a little bit longer, and our internal users were coming to us after like an hour asking for their data. And we're like, why do you need it so fast? Like, we're surprised you even noticed this. And they're like, oh, we use it. Like, the scientists will monitor things, and the scientists will monitor what's happening in the lab throughout the platform now as well. So I didn't know that until last week when we had a problem, but I guess they are using it a lot internally as well.
Another Lonza person. So I'm Ruth Rowland-Jones from Lonza. Firstly, thank you so much for the talk. I have a lot of questions, so I'm not going to do them now, all of them now. So I will come and catch you maybe in the lunch break. Yeah. Just to have two questions, if I'm allowed, if there's time. You mentioned, or I suppose you didn't mention, but it was on one of your slides around manufacturing component. I'd be curious to know, is that a future plan to pull in manufacturing data? Yeah, we're hoping to start that this year, but we haven't officially started it yet. There's all of the validation around that, and building like a validated data lake that we haven't started, but we definitely want to do that. And perfect, thank you. And then actually you mentioned validation, and that was part of my second question. So I know that it's process development data that's going in, but obviously a lot of that data is still supporting regulatory submission. Mm-hmm. Are these data pipelines validated? I think you just mentioned there that the data lake isn't validated. So what was the process then, I suppose, in terms of that discussion and determining what level of validation would be required to support? Yeah, right now, I don't know if it was on any of the pictures, but there's a banner at the top of PROGRAMview that says this is a non-validated system. If you're going to use this data for regulatory use, please contact us. So none of it is validated. We do have a ton of testing on every aspect of our pipeline. So when we do decide to validate, hopefully we're set up well for that. But as of right now, if the clients are going to use this data for any sort of regulatory decisions, we'll have a discussion about that, and we can confirm the data before we give it to them. Okay, perfect. Yeah. Thank you.
Hi there, Adam from Ziffo. Thanks for the presentation. I've got a question that's more around not the tech. You said that there were 7 spreadsheets, I think, or that sort of number in and around processes. Did you have to do process harmonization across the different sites that you displayed prior to doing that? And if you did, how challenging was that?
Yeah, that's probably one of our biggest challenges. But yeah, we have 7, which is pretty small because we really did try to align our sites and even as much as possible the different like cell classifications. And that was probably what took the longest part for developing the spreadsheets. But luckily, we're at a place now where we don't have to manage so many different spreadsheets in these pipelines.
Thank you.
Mm-hmm.
I don't think there are any more questions. Thank you very much, Christina, especially for doing it when you're not feeling 100%. So thank you.
Thanks, everyone.